Hi, this is Sharan, and this is my project submission for the main project, which is a password-based door lock system. I used a dsPIC microcontroller and a hex keypad, the microcontroller, the LCD display, potentiometer button, active buzzer, LEDs, snap debugger, and lots of wires and resistors. So it took 534 lines of code to make this, and interfacing two different devices into the microcontroller, and various other things including internal pull-up configurations and LCD interfacing. So let me program the device. So what this does is basically provides a door lock system where if you enter the right password it will allow you, and if you enter a wrong password it won't allow you. So the program is complete. Now the display says enter password. I'll push this a bit. The display says enter password. Now the initial password is 123456. It's a 6-digit password. So I'm entering the password 1 2 3 4 5 6. It accepts it and says the password is correct. The door opens and then the door closes in some time. Now after the door closes, when the next user wants to use it, or later if the user wants to use it again, he might again enter the password. If he enters a wrong password. Alright, that's a wrong password. Let him enter a wrong password again. It says wrong password and the buzzer starts bleeping. Let him enter a wrong password for more than 5 times. If the person enters a wrong password for more than 5 times, he might most probably try to break in. So we have to stop that. So in order to prevent that, if the user enters the wrong password for more than 5 times, the alarm should start beeping continuously without any ways of turning it off until the authorities arrive. So there will be a reset button which could turn off the alarm if in case the user enters more than 5 tries. So I think this is my 5th try. It says wrong password and too many tries. So this is too many tries, and the alarm system keeps on bleeping for a long time. If this was in production, the person would contact the authority, and the authority would find the hidden button, which is this button which is present here. And if the user presses this button for a long time, then the system will be resetted back to its original state. So let me wrong press it. So the system is back. Now the user can again try to enter the password again. Password correct. So if the user wants to change to his own password, even that can be done. So in order to change the main password, the user has to press the reset button. So if the reset button is pressed again, now the user can enter his new password. Let me enter my new password as 6 5 4 3 2 1. Password reset is now complete, and now the new password would be 654321. The door opens when I enter the new password. If I enter the old password, the door will not open. It says wrong password now. And the working of this code, I can explain the code. So these are like default configuration settings, not much use there, and a few libraries, even not much use there too. And these are the names we'll use for each pin. So D1, D4 to D7 stands for the LCD, and X1 and Y, X and Y stands for the rows and columns for the hex keypad, and green LEDs to indicate that the door was opened, and the red LED to indicate that the door is closed. And change password is function to change the password. Delay, LCD set bit, LCD command, LCD clear, LCD set cursor, LCD start. All these functions are used to program the LCD. And this is to initialize the port, to let the compiler know which is the input port and which is the output port. Also, I need to enable an internal pull-up resistor for all the input ports, because without a pull-up resistor, the function might randomly choose between 1 or 0, and it is essential for us to maintain all the input ports for smoothly operating it. Or there are a few errors might occur while in the read ports. So we have enabled those. So in the absence of any external input, the ports are naturally assumed to be 1. So that is how you can get the reading from the hex keypad and the buzzer. Now this function is for the character keypad scanner, and so this is how it works. If I press 1, then the first row gets connected with the first column, and that gets detected in this scanner. And this function is for the for the buzzer to be beeping 4 times. This is to open the door. This function is called when the door closes, and this is to scan for the switches continuously. This is the function to change the password, and this is the main function. So initially the LED prints. So the LCD set cursor calls a few other LCD programs and automatically sets the cursor at the first position here. Since we have very less ports, I had to operate it in 4-bit mode, and I was successfully able to complete it. And also this function is used to print the phrase which is given inside the quotes. And also here the input is red, and here the loading symbol occurs, and it compares whether the password entered and the actual password is same. If it is same, then the correct password correct password appears on the screen, and the door opens and closes. If it's the wrong password, then the wrong password is displayed on the screen. And if the user tries more than 5 tries, then instead of saying try again, which comes here, instead of saying try again, it should say too many tries, and the system should be and only if the reset pin goes back to 0, the system should be reset, and it should go back to normal. Else the alarm should continuously be firing. So that's the whole code. The editor used this MPLab, and the processor used this dsPIC33ck MP506 program, and this project is for the embedded systems design under Professor Joshua Keys in University of New Brunswick. Thank you.